Remember, trigonometry is all about ratios. And what we start with, we have sine, cosine, and tangent, which are ratios based on we can determine this angle and this side of a triangle. And there's a pattern there as far as what the length of this would be based on how big the angle is. And what we start with is we have right triangles, and that's where SOHCAHTOA comes from. And remember to always start with the angle. We want to start with the angle because the angle determines that across from it is what we call the opposite side, and right next to it is the adjacent side. And obviously always across from the right angle is our hypotenuse. And that's what, when we look at SOHCAHTOA, we have the S, C, and T gives us our sine, cosine, and tangent, but the O and the H is opposite and hypotenuse. And the A and the H is our adjacent and our hypotenuse. And then the O and the A is the opposite and the adjacent. And these are the basics for us to be setting up our ratios correctly. And that's what we're looking at here. When we're using SOHCAHTOA, we're basically just setting up proportions, setting up ratios based on the angle and then the sides. And the sine always goes with opposite and hypotenuse. Cosine always goes with adjacent and hypotenuse. Tangent always goes with opposite and adjacent. And that's where we get our word SOHCAHTOA from, is to help us remember how to set up these ratios. In addition to our trig functions sine, cosine, and tangent, we also have cosecant, secant, and cotangent. Now, sine and cosecant are reciprocal identities, cosine and secant are reciprocal identities, and tangent and cotangent are reciprocal identities. What that means is that since we know sine of theta is equal to opposite over hypotenuse, the cosecant of theta is equal to the hypotenuse over the opposite side. And cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And tangent is opposite over adjacent, so cotangent is adjacent over opposite. Let's say that we're given this right triangle and we're asked to find the value of these 6 trig functions. And we know that we always start with the angle, and so that would mean that 4 is opposite. And here's our right angle, so 5 is the hypotenuse, and we're not given this side. Remember, it is a right triangle. We can use Pythagorean theorem, a squared plus b squared equals c squared. Remember that the hypotenuse is always c squared, and then the legs make up a and b. Unless you recognize this as a 3, 4, 5 triangle, then that makes it even shorter. Now, because we have our angle right next to this side, here is our adjacent side. So when we use SOHCAHTOA, sine again is opposite over hypotenuse. Here's our opposite, here's our hypotenuse, that would be 4 over 5. Now if sine of theta is equal to 4 over 5, then we know that the cosecant of theta would be equal to the reciprocal 5/4. Cosine is adjacent over hypotenuse, that would be 3 over 5. That means that secant is equal to 5 over 3. And tangent is equal to opposite over adjacent, that's 4 over 3, which means that the cotangent is equal to 3 over 4. And there we can use SOHCAHTOA to find sine, cosine, and tangent, and then knowing that they're reciprocals helps us find the other 3 trig functions. Now here's some basic identities that we're going to be using throughout the semester in trig. And we've already mentioned the reciprocal identities where sine is equal to the reciprocal of, we have 1 over cosecant, and then cosecant is equal to the reciprocal there of 1 over sine. We have the same for cosine and secant, tangent and cotangent. A couple other identities we have, these are the quotient identities. The tangent of theta is equal to sine of theta over the cosine of theta. Now because that's true, and we know that tangent and cotangent are reciprocals, then that means that the cotangent of theta would be equal to cosine of theta over the sine of theta. Let's say that we're given the cosine of theta is equal to 1 over 3, and we're asked to find the 5 remaining trig functions. So we know cosine of theta is equal to 1 over 3, which, again, that gives us the secant then. Secant of theta would be equal to 3 over 1, which is just 3. Now, as far as finding the others, If in doubt, draw a triangle. That's going to be our rule for the semester. We can always draw triangles to help us set things up. Now if we know theta is our angle and that the cosine, remember cosine is adjacent over hypotenuse, gives us 1 over 3. So here's our hypotenuse, that would be 3. Here's our adjacent side, that would be 1. Now we can use Pythagorean theorem to find our other side here, our opposite side. So we'd have 1 squared plus b squared is equal to 3 squared. So then b squared is going to be equal to, that's 9, we'll subtract the 1 over, that would be 8. Square root of that, we can simplify as 2 square root 2. So our opposite side would be 2 square root 2. So now we can write out sine of theta would be opposite over hypotenuse, 2 square root 2 over 3. Tangent of theta is going to be opposite over adjacent. So that would be 2 square root 2 over 1, which is just 2 square root of 2. Now cosecant, we would take our reciprocal, 3 over 2 square root 2, rationalize the denominator. That's going to give us 3 square root 2 over 4. And 1 over 2 square root 2. Again, rationalize the denominator. We end up with square root of 2 over 4. So that's how we can use the triangle to help us set up and find the 5 remaining trig functions.